Good day, my YouTube viewers. I am here once more to sensitize us or to solve question in chemistry, and it is why I can pass question. So the question we are going to look at right away is under general gas equation, and the question is written on the board as you can see. The volume of a sample of methane collected over water at a temperature of 12 degrees Celsius and a pressure of 700 millimeter mercury was 30 centimeter cube. Calculate the volume of the dry gas at STP. STP means saturated temperature and pressure. And we are given the saturated vapor pressure of water at 12 degrees Celsius to be 10 millimeter mercury. So without wasting much of our time, let's write out the formula for the general gas equation. So there we have this P1 V1 over T1 is equal to P2 V2 over T2. To solve this particular question, you have to apply this formula. So from the question, the pressure, that is the initial pressure 1, is given. Let's look at the question. The volume of a sample of a methane collected over water at a temperature of 12 degrees Celsius and a pressure of 700 millimeter mercury. Pressure P1 is given to be 700 millimeter mercury. And then volume 1 is also given. The volume is given, let's look at it, to be 30 centimeter cube. That is V1 equals to 30 centimeter cube. Now, T1 is also given, that is temperature 1. It is given to be 12 degrees Celsius. 12 degrees Celsius. And before you can make use of temperature in calculation, you need to convert the degree Celsius to Kelvin. And how do we do that? We do that by adding 273. That is plus 273. So T1, by the time you add 12 to 273, you are going to have 285. I now have 285 Kelvin. So this is what I'm going to use during my calculation. Now, P2 is a standard pressure. It's always given. So the value of P2 is constant, and that is 760 millimeter mercury. 760 millimeter mercury. The volume 2 is not given. That is what we are asked to find. That is the final volume. So V2 is not known. Now, T2 is also known. T2 is a standard temperature, and it is always given to be 273 Kelvin. That is 273 Kelvin. Now, what are we looking for? We are looking for the final volume, that is V2. So to calculate V2, we make V2 the subject of the formula. And how do we do that? We have here V2 now will be equals to P1 V1 T2 over P2 T1. So we can substitute our values in the formula. Now we have the formula right here. So V2 now is going to be equal to, P1 is given to be 700 millimeter mercury. But don't forget, the standard value for saturated vapor pressure at 12 degrees Celsius is 10 millimeter mercury. So we are going to subtract 700 from 10 millimeter mercury, and that is going to give me 690. So the value we are going to use for the initial pressure, which is P1, is going to be 690. So I have my 690 multiplied by V1 is given. V1 is given to be 30, that is 30 centimeter cube, times T2 is also given, that is the final temperature, which is 273 Kelvin, over P2 is given, that is standard pressure, that is 760 millimeter mercury, multiplied by T1 is also given there. After the conversion to Kelvin, we have 285. So therefore, V2 equals to, when you multiply the numerator, all the figures there in the numerator, we are going to have 565 1100. Then you divide it by, when you multiply the numbers at the denominator, we have 216, then 600. So by the time you do the rest of the manipulation, when you do this division, you are going to get 26.10 centimeter cube. So this is our final pressure. So from the question, we use P1 V1 over T1 equals to P2 V2 over T2, and at the end of the day, we get our final volume to be 26.10 centimeter cube. This is what we do in this our channel. Watch and click the subscribe button to subscribe. Thank you.